Good afternoon, everyone, and welcome to Field Notes. My name is Crystal Briggs, and I'm a soil scientist in Mount Vernon, Washington, and the Field Notes regional representative for the Northwest Soil Survey region. As a regional representative, I serve on the Field Notes Review Committee. The Review Committee solicits and selects topics for each webinar. We have selected one exciting topic for today's live event, but first, let's go over a few housekeeping items. This is a Microsoft Live event, not a Teams meeting, which means you are joining today's webinar in listen-only mode. We encourage you to ask questions at any time using the Q&A panel. The Q&A panel should open by default. However, if for some reason your Q&A panel is not open, simply click on the question mark icon located in the upper right side of your screen. For closed captions, turn on the live caption button located in the lower right corner. Today's session is being recorded. Recorded sessions are available in Teams on the Field Notes channel and the Soil and Plant Science Division's YouTube channel. Again, thank you for joining us, and I hope you enjoy today's session. With that, I'd like to turn it over to the Field Notes moderator, Neil Dominy, to tell you a little more about today's webinar. Take it away, Neil.
All right, thank you very much, Crystal. First of all, for those who don't know me, my name is Neil Dominy. I am the director here at the National Soil Survey Center. I've been on board for about 3 weeks, and I am super stoked about the opportunity to help host the Field Notes session, and excited to see all the good things that the Soil and Plant Science Division is up to. So getting on to today's topic, we have a special presentation on soil survey update on a reclaimed surface coal mine in southwest North Dakota. Krista Bryan from Dickinson, North Dakota will be bringing the presentation today. Go ahead, Krista.
All right, can everyone hear me okay?
Yes.
Perfect. All right, as Neil said, my name is Krista Bryan. I am a soil scientist in the Dickinson, North Dakota MLRA office. And welcome to my Field Notes presentation on updating a soil survey on a reclaimed coal mine in southwest North Dakota. North Dakota is home to the largest lignite coal mine in the United States. They mine about 500 acres per year and ship 14 million tons of lignite. Lignite is a low-quality coal. It has more water than higher-grade coals such as bituminous and anthracite. Lignite is not cost-effective to ship out on railroad car, so if you see that, that is going to be one of those higher grades of coal. Instead, it is burned for electricity on site and then transported via power line. There's also a gasification plant at the Freedom Mine, which is what this study is on, that creates natural gas, ammonia fertilizer, DEF for diesel vehicles, carbonic acid, and other products. Lignite seams in North Dakota can be a few inches thick up to 40 feet thick. They can also be near the surface or over 1,000 feet down. However, they are only economically mined if they are at least 10 feet thick and are no deeper than 175 feet below the surface. Usually we see them in the Sentinel Butte geologic formation, we're in North Dakota. Coal companies use a large crane-like machine with a bucket called a dragline to dig the strip mine. The buckets typically hold between 60 and 150 cubic yards of overburden material. Shovels and hydraulic excavators can then load coal and other material into large dump trucks to transport the material. And you can see on this picture on the right how big these dump trucks are. Like that is a full-size pickup. It's a little hard to see to the left of that dump truck. If there is harder material, the mines will also use explosives so the dragline can get the material out easier. So for the reclamation process, in the 1970s, reclamation criteria was established in the North Dakota Century Code for surface mining activities. Criteria to reduce environmental impacts and to return the land to similar usability was researched heavily before implementation. Topsoil and subsoil are both removed and stored in separate piles for later use. Although sometimes when the mine is actively digging and reclaiming at the same time, they may just take that freshly dug stuff and reclaim it right away. But when they do pile it, the piles are leveled and then seeded to help prevent erosion. When it is time to reclaim, the spoil is laid down first in a way that mimics the previous natural landscape's topography. It is somewhat compacted to help prevent subsidence, but care is taken to not overly compact it. Then subsoil is laid down, followed by the topsoil, and then the area is seeded and observed. The amount of respread, which is the topsoil and the subsoil together, needed is dependent upon certain criteria from the Public Service Commission. And that criteria is based on research from North Dakota State University. Mine operators can loosely tell the difference from the material based on color, so there is some mixing of horizons, but typically the topsoil material is A and BW or BT material. The subsoil is BK and C material, and the spoil is going to be our soft shale, sandstone, or siltstone for the most part. The combined thickness of the subsoil and topsoil material is what it needs to meet that thickness criteria. And a specific ratio of topsoil to subsoil is not exactly established. That being said, they don't just put only topsoil or subsoil on an area. Typically, there's at least 8 inches of topsoil on all of the areas that are reclaimed. The total respread criteria is dependent upon texture and the chemical criteria of the spoil. Spoil with a sodium adsorption ratio below 12 has the least amount of respread required at 24 inches, followed by an SAR of between 12 and 20, which is a respread of 36 inches, and 48-inch respread has the greatest SAR of over 20. I will address specific sodic material information in greater detail later on. Sandy material also requires a respread of 36 inches to help with water availability for vegetation. The Bismarck Soil Survey Office previously mapped the Falkirk mine, and they did set up series that correlate with these respread depths. And on the table here, you can see that the soil box cut is for respread soils of 24 inches, Coal Harbor for 36 inches, and Knife River for 48 inches. So before the reclamation criteria was put into place, things did not need to be reclaimed. On the left here is overburden piles that were just left. And then the excavation was allowed to be filled with water. The spoil piles look pretty reminiscent of the Badlands, which are in western North Dakota, as then they have a lot of bare areas. And then if you see the bottom picture on the left, the vegetation grows better on the north sides of these things because there's more moisture there and slightly cooler as we have really hot and dry summers. Picture on the right is an aerial view, and you can see how the drag line laid down the spoil piles, and you can see where the pit was. It follows the curve of the spoil piles. Right now, this area is known as Harmony Lake. It is a wildlife area, and the fish and game own it. Currently, the process, the topsoil, subsoil, and spoil are all stored in separate areas until they are needed. The topsoil and subsoil piles are seeded to help prevent the erosion. So you can see on the left here, there's an open pit, which has been fully, they're finished with this pit and they're going to reclaim it. And all the material that they had taken out are stored in piles like on the right. And you can see where they do level the top out, so it's not like a steep patch on top. Restored cropland areas typically have lower relief and are in A or B slopes. Many crops have been grown successfully on these areas, such as canola, wheat, soybeans, corn, and sunflowers. Wetlands are also recreated on these areas. Restored pasture you typically see on the steeper slopes here. They typically have C and D intermingled with B. They seem to be seeded with tame and native seed mixes. Here's an aerial view of the mine. The aerial imagery and the elevation don't quite match up. They are different years, but you can see that on the north side, the ground has a lot of microtopography to it. There's a lot of bumps. And then there's the linear feature, which is the active coal mine. And then south of there is the area that has been reclaimed, and it is very, very smooth. And then you can also see where the spoil piles are. Those are those raised rectangular areas. After the mine reclaims the land to the required criteria, they need to demonstrate that it is producing the same or better than it was prior to mining. They submit an application to the Public Service Commission, who does their own independent verification. If the Public Service Commission signs off on it, the mine is released from their bond. The mine then gets all the money that they put into the bond back. If the mining company goes out of business or is not able to finish the reclamation process themselves, then the bond money would be used on behalf of the mine to do the reclamation. So this way we are not left with any unreclaimed mines. Currently, this area is mapped as mined land complex, 0 to 60% slopes, and that is not adequate for conservation programs. These newly engineered soils have very different properties than natural soils that were there before, so they also would not be captured if we had the historical soil lines in there. So we need to create a new product. Our main concerns going into this project were dense areas, subsidence areas, sodic areas, and areas with high carbonates. So far, we have not found a really dense area aside from areas where the ground has subsided. These typically form a very shallow depression and hold up water like this picture on the right. This spring, we are going to do more bulk density sampling and investigation on these areas. Carbonates in some areas were strong at the surface, and this is a concern as they can impact plant growth and the susceptibility of the soil to wind erosion. This pit on the right here was dug on reclaimed mine land. Notice the very abrupt and smooth boundary at the topsoil. The difference between the spoil and the subsoil is a little more difficult to pick out on this profile. That does vary from pit on depending on the material that was respread. We describe any plow layer as an AP, followed by the rest of the topsoil being an A, and the subsoil being a C1, and the spoil being a C2. The C1 is composed of mainly BK and C material. We don't describe them as B horizons as their structure is pretty destroyed and any pedogenic processes are kind of reset in a sense. Our C2 is mainly CR material, shale and mudstone, but we can also have sandstone. We are currently investigating the use of a D for our densite horizon in these soils. On the free to mine, the textures were very consistent with a clay loam or loam surface, a clay loam subsoil, and a clay or silty clay spoil. We expect this to vary at the other mines within the state. The depth of respread, that's the subsoil and topsoil together, depends upon the chemical and textural properties of the spoil, which we discussed earlier. Here are just some more examples of the soils we found there. On the far left is some typical spoil material. You see it's pretty clayey. The next one is a rare instance where I found some sand grains in this specific mine. Next picture is the topsoil, the subsoil, and the spoil just kind of put together so you can see them side by side. Next core has a very dark A horizon, and there's actually coal in the spoil material. That did happen occasionally. And on the right, you can see kind of a more typical soil core that we'd find there with an A, and then the subsoil, and then it goes to the spoil where you start seeing that kind of orange redox and gray color. Some general soil properties we have noticed. Some topsoil in the pasture areas are starting to show some subangular blocky structure forming, but for the most part, these soils have massive or cloddy structure. So far, the majority of the mine soils are not as dense as we would have predicted. The volumetric bulk densities have been around the 1.3 to 1.4 range, aside from those areas that have subsided, which we so far have seen 1.6 to 1.8. However, the respread layers can be difficult for water to initially penetrate, and maybe that layer right there is the most dense part. It may be valuable to run some water table studies to see how this water moves and changes throughout time in this system. Roots also may mat and follow cracks in the material, and this photo on the left really shows a good example of that. And the photo on the right shows where a producer has taken a ripper trying to break up that layer between the topsoil and the subsoil. There are areas out there that are quite obviously drowned out, like this picture on the left. There are also the area also shows patchy areas in unharvested canola, which is the picture in the middle, where the crop just never germinated this year, or it died shortly thereafter. The stubble you see on the picture on the right is actually last year's planting, and then the tall stuff is from this year. A few volumetric bulk densities that were taken from these areas show that within this low stubble area, the bulk density was 1.6 to 1.8, and then immediately outside, it had decreased to about 1.4. Our thought is that these areas have settled, making a slight depression and a higher density. This spring, we're planning on taking some more samples in these areas and surrounding areas to see if maybe a Dunsink minor component is a viable idea for our legend. So in the top left and in the top right on the right picture, you can see there's a kind of a dark strip in this wheat stubble. Upon investigation, these areas were found to be just bad quality stubble compared to the white areas. The topsoil is much shallower in these areas and did not match the respread map provided by the mine. It could have been a mistake made during the construction of the soil. There's definitely going to be a production impact that could possibly be a thin topsoil minor component on the landscape, possibly. Areas that have a thin calcareous topsoil, which we have found, could also have much greater conservation and production concerns. Sodic spoil material. So sodic soils are soils that are impacted by sodium. Sodium has two main detrimental factors. It disperses the clays, making hardpan layers and destroying structures, and it makes it difficult for plants to uptake water. The sodium comes from North Dakota's sedimentary parent material, which is marine in origin, as this area used to be a shallow sea and kind of coastal. The sodium and other salts can move up to the profile in a couple of ways naturally. One is during years when net precipitation is below evapotranspiration, which brings the salts up through the profile. The other occurs when water moved along a coal seam or a sedimentary bedrock, pick up sodium salts and sulfates. This water can then discharge at a lower landscape position, and when it's discharged on the surface, it can create a saline seep, which looks similar to the picture on the right, or on the bottom left, bottom center. So this is a drain, like a drainage, but a saline seep will have that kind of light, that white crystals on top, and then the top shows what the structure looks like on these areas where it's just massive and there's not much things that can grow on them. That plant there is a saltwort, and it has a special adaptation to grow in high salt areas where it will actually shed sodium out of its pores. The picture on the right is of some coal and sulfur in some sedimentary bedrock in North Dakota. Will the sodic material impact the topsoil on the reclaimed mine lands? Should we be concerned with at what depth the sodic spoil is? The respread depth criteria relative to SAR was put into place to help mitigate any effect on the topsoil. There are a few long-term studies that look at how the SAR changes in these engineered soils through the years. Within the first few years, the sodium can move rather rapidly through the profile, mainly due to diffusion. This is due to the ionic gradients being so different, with the material all just being stacked back on top of each other. The system then seems to stabilize, and in a 16-year study in Alberta, which does have very similar parent materials and reclamation processes as North Dakota, they found that after the initial adjustment period, the sodium moves pretty similarly to native soils. We can then expect that these reclaimed soils should have a similar sodium risk as undisturbed soils at that point. more long-term studies are needed, which is why we think it is important to document depth within our series. The soil on the right is a clay pan soil that has been affected by sodium. So you can see kind of the dispersive nature that the sodium causes on these particles. So how can we create a useful soil survey product to meet our customers' needs? Has there been enough time for pedogenic properties to make themselves evident in these soils? And what other features could we possibly identify to make a useful product? The mine has a map of all the areas they have reclaimed with associated lab and depth data. 5 series were created by the Bismarck Soil Survey Office for the Falkirk mine in North Dakota previously. 4 of these series are applicable to the Freedom mine. Their series horizonation needs to be updated as these were made a little while ago, but we did take them as a base. Box cut again is the 24-inch respread, Cole Harbor the 36, and Knife River is the 48-inch. Dragline is a series for wetlands. The Bismarck office created phases to account for other aspects of the soil, such as a thick topsoil phase. We used the respread map from the mine and assigned the general series that were created for the Falkirk mine to this map. A slope map was then overlaid and any polygons under 3 acres were merged. This is a general map we took with us to the field for investigations, along with the straight respread data from the mine. This was for general investigations on the landscape and for determining if the data from the mine was applicable to what we could identify. So if you look at the map, there is a big Knife River B polygon. So most of the soils there should be a 48-inch respread on B slope. We did 15 transects, and we did just general ped-ons and field investigations this year. In total, we had 110 field observations. Data correlates well to what the mine gave us, but depending on the material, sometimes it was difficult as a soil scientist to determine whether the 24-inch or 36-inch respread, which one it was. If we had a field lab method for determining SAR, I assume the determination would be easier. It does call into question on whether these series should indeed be distinct. Lab data for all these points is in the process of being collected from the mine. They have an archive of lab data that they themselves have conducted. And then we will look into that lab data once it is received. It has things such as texture, SAR. The topsoil groupings were not as accurate as the entire respread, and they appear to have more variation. We could look into adjusting our breaks, because currently how we have them broken up is that a thin topsoil would be below 9 inches, a typical topsoil between 9 and 12 inches, and thick would be anything over 12. And this 3 inches is really not a lot of material when you think about these big machines that they are using to reclaim the area. So that may just not be adequate. Right now, if it was supposed to be a typical and it was just 3 inches higher, it could be a thick instead. And you can see that on the chart I made on the right. So if we went to on our pre-map, the delineation was supposed to be a box cut. 56% of the time with the ones we visited, we found box cut as the mainly. Cole Harbor, 81%, Knife River, we found Knife River 79% of the time in those delineations. And the topsoil we get 40, 20, and 48 respectively. So that's something we'll need to look into a bit more. So the key characteristics we want to capture and show on our map at the end is the depth of the spoil, the slope, carbonates if they are near the surface, texture, the depth of the topsoil, the drainage, and the density for areas that are root restrictive. So we came up with a preliminary legend this winter. It seems like the 24 and 36-inch respreads, which are the box cut and cool harbors, could be made into a complex. And then there should maybe calcareous, dense, thin, and thick topsoil phases. That is a lot of minor components for the map unit. So this spring we are going to do a little more intensive calcareous surface study to see if there's actually maybe a calcareous map unit that if they're more prevalent in certain areas of the mine and that they could be set up. Dense as a minor component is also to be investigated for validity as a component this spring. The Knife River tended to be a bit more uniform and could be mapped as a consociation on those lower slopes. But when I got to a sea slope, you seem to run into those lower or shallower to spoil soils. Wetlands should just be the drag line for consociation. There's also going to be an Ustorthens fluviquens complex, and this is going to be for these drainage waves that the mine has left. They have scraped the topsoil off as to not get them contaminated with sodium and other stuff from the spoil. And once everything up top of the watershed has been reclaimed, they will reclaim those areas. But for now, they are disturbed. Then we're also going to map a natural soil Ustorthens complex. So an example would be like Williams Loam Ustorthens complex. And these are going to be for areas that were disturbed, but they were not mined. So they may have had gravel piles on them or spoil piles on them, or just used for roads or something like that. And for this mine, there is a very large portion of urban land complex. There is the mine itself, there's a gasification plant and an electricity producing plant, and it takes up quite a bit of area on this mine. We still have quite a few questions on this. Mainly is, should phases or new series be created for these? How many series do we want to have? Can we utilize water table studies to capture the soil water dynamics in place of field indicators? And how will depth continue to play a role in the soil development as time goes on? This summer, we are going to do some map verification and investigation on our preliminary legend. We're going to collect additional bulk density samples and those calcareous samples, and we're going to have a field review with our technical team. And something kind of cool in this mine is there's actually quite a bit of wildlife, and here I found a moose one day. He was right in my transect line, and I got a picture of him before he ran away. Future projects, so the Freedom Mine we're hoping to have completed in 2024 in the fall. There are more mines to follow. There are 7, I believe, that I found in our long-range plan. A lot of them are kind of clustered, so that cluster of 5, kind of a bit more in the center, that's where the Freedom Mine is and where a lot of the other mines are. And then there are a few as you go southwest. And those soils to the southwest, I'm sure, are going to have a lot of different properties than the ones we found on the Freedom Mine. All right, with that, I have time for some questions.
All right. Thank you, Krista, for the great presentation. Beautiful pictures. It's always great to see a moose in North Dakota, and very cool pictures with the profiles and able to see the soil structure. Those are great. There's a few questions here that have came in through the Q&A chat. One mentioning how cool that the mine is sharing historical soils data. I thought that was pretty cool too, Krista. Was that hard to ascertain that type of information on how their reclamation process?
So we sat down with the mine and we had a pretty good conversation with them, and they've come out with us a few times. We've talked about what we've seen. They have a few videos out too, and they were very willing to give us their respread layers. So we had a lot of cooperation from the mine, which has been really nice.
That's great. And along that line, is there some, are there some real derivatives that the mine or the company can benefit from the data that we collect, or are we still working on that end of things?
I think we're still working on it. One thing they are interested in is like how trees can establish. They've been using some of their own own studies for that, but I'm sure they'll be using it as well.
Very good. Then a couple questions here that we'll just see if you have any knowledge of other areas, but here's the question. Are densic components common in other reclaimed areas?
I know for like they use like the CD, like a common, mine soil is like a common example of densic areas. So I do think that it is pretty common for mined areas to have that densic layer in there. For these ones, were not as dense as I was expecting them to be. But again, we will look more at it this summer. But yeah, from what I understand, mines typically have pretty dense areas.
Very good. And just a reminder, if there's any other questions, feel free to post them in the Q&A pod. Couple more questions here for you, Krista. How do reclaimed soils relate to urban soil / human altered, human transported criteria?
Yeah, so when the artisols come out, I did look at the current proposal. I think it's version like 39 right now, and they do classify quite well in there as, was it a port arthart or something similar to that. So yeah, there is a special place in there where they do fit quite well for that. It fits in where there's a massive amount of soil that is taken off and then put back in.
Excellent. Here's a question for you. Was erosion a concern with your mineland soils? Did you do anything about older mines that haven't been restored or reclaimed yet?
Erosion, so there are areas where there's strong calcareousness on the surface, and those are going to have a bigger susceptibility to erosion for sure. And when people do practice no-till out here, which I think is really beneficial for these soils, since they don't have a lot of structure and they can puddle really well with raindrops and stuff. So I think that has definitely really helped with erosion on these areas, and that these are they reclaim them as such gradual and smooth areas for the most part, for the cropland anyway, that I think that really helps with the water erosion. We have not worked on older mines yet. This is our first mine, kind of our first foray into some urban soils. But we will definitely be running into that later on, especially there are mines that were done before the 1970s that don't have those criteria. They were reclaimed before they had those criteria. So in the future.
All right, very good. Do you know what factors limit reclaimed areas from completing the reclamation process?
I'm not quite sure what that question is getting at. You know?
Well, we can jump over that one. I'm not a reclamation guru on reclaimed areas as well, so I'm guessing it had something to do with if there's certain rules to get through a reclamation process, if there are certain things that are hard to overcome. All right, let's go. This is the last question that's in the pod as of right now. Are the crops and pasture forage that are seeded safe to be used or grazed right away?
So the mine has to prove that production is to previous pre-mine levels. And to do that, they sit on the land for, I want to say it's around 7 years, but don't quote me on that. But they have several years where the mine monitors it, and it's in grass. So I think they may forage it, but they don't crop it at the beginning, and it takes a little while before it gets established. In terms of safety, there shouldn't be any, in terms of like, I don't know if there's like heavy metals and stuff like that, like you see in some mines. We don't have that issue here, just the sodium from the main part in the spoil. So yeah, there is that wait period before it goes back to like a producer to do a heavy production off of them.
Very good. Someone stole my question. Here it is. Any consideration to trying out GPR or other remote sensing tools on these areas, or are you already doing that?
I've been thinking about doing some kind of like remote sensing of it's like satellite data to pick out like those depressions maybe for like composition of our map units. I don't know much about ground penetrating radar, but I'd be willing to investigate things as we go forward and kind of figure out, like right our first year into doing this, we're just trying to figure out like how these soils behave, what it looks like. So as we go on, we consider more different options of investigating these soils for sure.
All right, and Krista, one last question. I know you mentioned more mines in North Dakota. Do you have any idea on the size of total acres that have the potential to be mapped with these practices?
Oh, I don't know the size of the other mines. I want to say the Freedom mine is around 50,000 acres right now, but yeah, I don't know the acreage of those other mines.
No problem. Well, thank you so much, Krista, for presenting to us all today. This has been very interesting, a great learning opportunity, I'm sure, for all. For those that are the attendees, I really appreciate the questions. I believe we had over 10, so thank you for your listening skills and your questions for Krista. It makes it way more engaging when we have that type of feedback. And Paul just put up here, please remember, we'll have our next webinar on April 9th. Please make sure you schedule around it so we can continue to bring you these great updates from across the U.S. So thank you all for joining us.